Okay, so for this next section, what we're going to look at are some applications of trigonometry. So we're going to look at some word problems. And there's two terms that you need to know before we get started on this. So the first is the angle of elevation. So if you imagine that you were sort of standing at this point here, so there you are, and you were looking upwards. Okay, so if you were looking up at something that was say over here, so say you were standing at point A and you were looking up at something at point B, that angle that your sort of line of sight makes with the horizontal is called the angle of elevation. So here's the definition for you here. The angle of elevation from A to B is the angle the upward sloping line AB makes with the horizontal. So that's this angle here. Okay, and in the same way, if you were looking down, so say you were looking down at something at point C there, then that's the angle of depression. So this bit here, okay, is the angle of depression. So it's the angle the downward sloping line AC makes with the horizontal. So let's look at a couple of word problems to see where that's going to come in. Okay, example 1. A helicopter flying at a constant altitude of 91 meters sights the middle of a landing pad at an angle of depression of 16 degrees. How far in meters must the helicopter travel to be directly over the landing spot at an altitude of 91 meters? So when you're doing a word problem, you're definitely going to have to draw a diagram to begin with if you haven't been given one. So let's do that first. We've got our helicopter here, and it's flying at a constant altitude of 91 meters. So that means it's 91 meters above the ground. So I can kind of draw that in here. If I say, okay, this is the ground, that's 91 meters above the ground. So the helicopter, or the pilot in the helicopter, sights a landing pad. So obviously the landing pad is somewhere on the ground, so let's just say it's here. There's our landing pad. He sights it at an angle of depression of 16 degrees. So this angle of depression here is at 16 degrees. Now remember, that's the angle it makes with the horizontal. So the horizontal sort of line of sight would be here, but if you were looking down 16 degrees, that's that angle there. Okay, so the question is saying how far in meters must the helicopter travel to be directly over the landing spot? So directly over the landing spot would mean, I'll just put an H, that the helicopter is going to land, or the helicopter is going to be flying somewhere over here. Okay, let's think about this now. This length here, so if I draw this in, do you see I've got a right angle triangle? That length has to also be 91 meters because it's parallel to this line here, 91 meters. And what we want to find out is how far the helicopter has to travel to get to that spot. So we can label this with X. We're trying to find how far the helicopter has to travel to go from there to there. Okay, let's go through our steps in terms of labeling our sides, finding out our trig ratio, and then solving for X. Okay, so the angle we're given is 16 degrees, and X then would be the side that is adjacent to that angle, and the 91 meters that we're given is the opposite side. So let's just write down over here what we know. Okay, so we know the angle is 16 degrees, so theta, we'll call that, is 16 degrees. We know the opposite side is 91 meters, and the adjacent side is what we want to find out. Okay, so we can say that's a question mark, or we've labeled it X. Okay, so opposite and adjacent. Hopefully you've been writing this word so many times by now that you know it off by heart. But if we want to use the opposite and adjacent, we need to use the tan ratio. So tan of theta is equal to the opposite over the adjacent. Let's fill in what we know. We know that theta is 16 degrees, and that's equal to the opposite, which is 91, over the adjacent, which is what we're trying to find. So our next step now is we need to rearrange the formula so that we've got x equals something. So first step is we would multiply both sides by x. So x times the tan of 16 degrees is equal to 91. And then to solve for x, we're going to divide both sides by tan of 16. Okay, and hopefully you're okay with your calculator now. So when you put that into your calculator, you get an answer of 317.35 to 2 decimal places. Okay, so our final step would be to round our answer to the nearest meter, because we've been asked how far in meters must the helicopter travel, and to write a full sentence answer. So the helicopter would have to fly 317 meters. Okay, let's look at one more example. So in this example, we've got a swimmer who is 0.32 kilometers from the base of a cliff. Sorry, that should say from the base of a cliff, looks up and waves to her friend who's at the top of the 110-meter cliff. Find the angle of elevation from the swimmer to the top of the cliff. Give your answer to the nearest degree. Okay, step 1, draw a diagram. So I'm going to draw my swimmer in here, and I don't have very good drawing skills, so I'm just going to draw a stick person. There's my swimmer. And her friend is on the top of a cliff. So let's just say that's my cliff. And there's the friend standing at the top of the cliff. So the swimmer is 0.32 kilometers from the base of the cliff. So let's draw that in. So that's the water there. And that distance is 0.32 kilometers. And the height of the cliff is 110 meters. And what we want to find is the angle of elevation from the swimmer. So if the swimmer was looking up, we want to find that angle of elevation there. So in this case, the horizontal is the water, and the swimmer is looking up to her friend. Okay? And hopefully you can see that the cliff and the water make a right angle. Okay, so let's label our sides. So the angle we want is here. So we've got the opposite and we've got the adjacent angle. Okay, so same as the last example, we're going to use the tan ratio. So the tan of theta is equal to the opposite over the adjacent. And we're trying to work out theta. The opposite is 110 meters. Now, hopefully you've noticed that this is in kilometers, and we need to have both of those measurements in the same units. So 0.32 kilometers is the same as 320 meters. Okay, you would just times that by 1,000 to go from kilometers to meters, because there's 1,000 meters in a kilometer. Okay, so back to our question here. Tan of theta is equal to 110 meters over 320. To work out theta, we need to use the inverse tan of 110 over 320. Okay, so you can go ahead and put that into your calculator. And you should get that theta is 18.97 degrees. So rounded to the nearest degree, we would get theta is equal to 19 degrees. Okay, so final step, write a full sentence answer. The angle of elevation, that's what we're asked for. From the swimmer to her friend is 19 degrees.